Welcome to This Explainer. Today, we're doing something pretty cool. We're taking some foundational concepts and transforming them into a highly dynamic blueprint for mastering data engineering. We're looking at data warehousing and business analysis, but we aren't just going to talk theory. We're going to treat this like a massive construction project so you can understand exactly how raw data actually becomes actionable business intelligence. Our overarching objective is crystal clear. We want to gain knowledge of a data warehouse, design it, and most importantly, implement it. It's all about building a highly functional warehouse from the ground up. And this quote right here is going to be our North Star. To get there, we've got a really clean 6-part roadmap. We'll start with the data warehouse blueprint, move into the ETL process, tackle OLTP versus OLAP, design schemas and MARTs, dive into multidimensional analysis and mining, and finally, map out your engineering learning outcomes. So let's jump right into Section 1, the Data Warehouse Blueprint. To build our warehouse, we obviously have to start by understanding its core characteristics and architecture. I mean, you wouldn't build a massive physical storage facility without knowing exactly how the weight is going to be distributed, right? Well, it is the exact same thing with data engineering. Grasping these architectural characteristics right off the bat ensures your warehouse can actually handle heavy-duty business intelligence down the road. Moving right along to Phase 2, moving data, specifically through the ETL process. This right here is essentially the supply chain of our entire data journey. The ETL process breaks down into 3 essential steps. First up is data extraction, where we're pulling raw materials from various outside sources. Second is transformation, which is all about cleaning and formatting those materials so they align perfectly. And finally, loading. That's where we place those beautifully organized datasets onto our pristine warehouse shelves so they're totally ready for use. Which brings us to a critical crossroads in Section 3, OLTP versus OLAP. Here we are contrasting 2 distinctly different systems. Online transactional processing, or OLTP, is really all about those quick, everyday transactions. Think of a cashier scanning a barcode at the grocery store. Super fast, very high volume. But on the flip side, online analytical processing, or OLAP, handles deep, complex querying. It's not looking at a single barcode scan, it is analyzing the sales trends of that specific product over the last 5 years across the entire country. Totally different ballgame. All right, let's head into Section 4, designing schemas and MARTs. So the real crucial point in organizing our goods effectively is dimensional modeling. And we kick things off with the star schema. Picture a literal star shape. You've got a massive fact table right in the center, holding your main data, and it's surrounded by dimension tables pointing outward. It is a highly direct, centralized, and honestly just a super fast way to arrange our data for querying. Then we have the snowflake schema. This acts as a more complex, highly normalized floor plan for our dimensional modeling. Basically, you take that star shape we just talked about, and those surrounding points branch out even further into sub-dimensions. Now, it's great because it saves space and reduces redundancy, but keep in mind it does mean you have to travel down a few more pathways to get all the information you need. Eventually, all of this architecture builds into data marts. Think of these as smaller, highly specialized storage rooms within our larger warehouse. Like, instead of letting the marketing team aimlessly wander the entire massive warehouse, you just build them their own specific data mart with exactly the data they need. It's an incredibly powerful organizational tool. Next up is Section 5, multidimensional analysis and mining. Before we look at the specific technical operations for this, we really have to pause and ask the ultimate business analysis question. How do we actually attain inference from these results? In other words, how do we pull meaningful insights from all this stored information? Because let's face it, what is the point of having a massive, perfectly organized warehouse if it doesn't actually help us make smarter business decisions? Well, we find those answers by utilizing OLAP architecture and OLAP operations to perform multidimensional data analysis. This is the really fun part where we start slicing and dicing the data. We're looking at it from multiple angles all at once. Imagine analyzing sales by region, by quarter, and by a specific product line simultaneously. You start spotting trends that are literally invisible to the naked eye. As we dig into uncovering these hidden patterns, it's also vital to confront the major issues in data mining. This is flagged as a self-learning topic for you, and it's absolutely crucial. You have to anticipate the challenges of finding anomalies, patterns, and correlations within these massive datasets.
Actually, scratch that. It's not just about anticipating them, it's about knowing how to navigate them so your analysis doesn't lead you completely astray. Finally, let's bring it all home with Section 6, your engineering learning outcomes. These milestones map out exactly what you'll be capable of. It tracks a really clear progression. You start by defining engineering fundamentals, then you identify OLTP and OLAP functionalities, and move right into applying dimensional modeling to real-life problems. It wraps up by challenging you to actually implement a warehouse via an OLAP cube and apply computer engineering principles to attain true inference. Complete with the exact PI codes, this is your comprehensive roadmap to total competency. So having systematically built this data warehouse blueprint from the ground up, from raw extraction all the way to multidimensional inference, there's really only one thing left to ask. Are you ready to apply the theory and principles of dimensional modeling to your next real-life problem? How are you going to use these foundational principles to conquer your next engineering challenge? Thanks so much for joining me for this explainer, and I absolutely cannot wait to see what you build.